Have you ever wondered what the final moments of our planet will look like? What will be the last thing Earth sees before our sun, the very star that gives us life, finally meets its end? It's a thought that is both terrifying and fascinating. For billions of years, the sun has been the steadfast heart of our solar system, a constant source of warmth and light. But like all stars, it has a lifespan, and its death will be the most spectacular and final show our planet will ever witness. This isn't science fiction. It's the inevitable destiny written in the laws of astrophysics. So let's journey billions of years into the future and witness the breathtaking, cataclysmic end of our world as seen from the surface of a dying Earth. Right now, our sun is in its prime, a stable middle-aged star known as a yellow dwarf. It's about 4.6 billion years old, and it's been steadily fusing hydrogen into helium in its core, releasing the energy that sustains all life on Earth. This process is a delicate balancing act. The outward pressure from the nuclear fusion in the core perfectly counteracts the immense inward pull of the sun's own gravity. This equilibrium is what has kept our star stable for eons. But this fuel, the hydrogen in its core, is finite. In about another 5 billion years, the sun will run out of hydrogen to fuse in its core. This is where the beginning of the end truly starts. Without the outward push from fusion, gravity will begin to win. The core will start to collapse under its own colossal weight, becoming incredibly dense and hot. This intense heat will ignite a shell of hydrogen surrounding the now inert helium core. This new furious burst of fusion in the outer shell will be far more intense than before. It will generate a tremendous amount of energy, pushing the sun's outer layers outward like an expanding balloon. This is the moment our sun begins its transformation into a red giant. From Earth, this would be a slow but inexorable change. Over millions of years, the sun in our sky would grow larger and redder. The increase in size will be staggering. The sun will swell to over 200 times its current diameter, becoming so large that it will engulf the orbits of Mercury and Venus. Our two neighboring planets will be vaporized, becoming nothing more than wisps of gas absorbed into the star. And what about Earth? Our planet's fate hangs in the balance. Some scientific models suggest Earth might just barely escape being swallowed whole, while others predict it will be consumed along with its neighbors. But even if Earth isn't directly engulfed, the conditions on its surface will become utterly apocalyptic. The sheer proximity to the bloated, fiery surface of the red giant will have devastating consequences. The first thing to go will be our atmosphere and our oceans. The sun's intense heat, thousands of times greater than today, will boil away every last drop of water on the planet. The oceans will turn into a thick, planet-encompassing steam, which will then be stripped away by the powerful solar winds emanating from the dying star. Our blue marble will be transformed into a scorched, barren rock hotter than an oven. The surface temperature on Earth will soar to over 1,000 degrees Celsius, or 1,800 degrees Fahrenheit. The ground itself will melt, turning continents and mountains into a global ocean of molten rock. Earth will become a glowing magma world. From this hellish vantage point, the sky would be an unbelievable sight. It would be almost entirely filled by the massive crimson orb of the red giant sun. It wouldn't be a distant point of light anymore. It would be the entire view, a terrifying, beautiful wall of fire. There would be no day or night, only a perpetual searing blood-red twilight cast by the dying star. The very air, what little remains, would shimmer with a heat that melts stone. This phase as a red giant will last for about 1 billion years. During this time, the sun will continue its internal struggle. The helium core, which had been collapsing, will eventually become hot and dense enough to ignite. In a cataclysmic event known as the helium flash, the sun will begin fusing helium into heavier elements like carbon and oxygen. This new energy source will cause the sun to shrink slightly and become a bit hotter, but it's only a temporary reprieve. The helium fuel will burn much faster than the hydrogen did. After only about 100 million years, the helium in the core will also be exhausted. The sun's core will once again be made of inert material, this time carbon and oxygen. Gravity will take over again, and the star will expand for a second time, becoming an even larger and more unstable red giant. It will start to pulsate violently, like a giant dying heart. With each pulse, the sun will shed its outer layers into space. Massive clouds of superheated gas and dust will be expelled, creating a stunning, intricate structure around the dying star. From the molten surface of Earth, this would be the final act. We would see our sun literally tearing itself apart. Great, billowing sheets of incandescent plasma would drift away into space, revealing the superhot core beneath. The sky would be a kaleidoscope of colors, not just red, but brilliant shades of pink, blue, and green, as the ejected stellar material is ionized by the intense radiation from the core. This is the birth of a planetary nebula. These nebulas are some of the most beautiful objects in the universe. They are the ghostly remnants of stars like our sun, glowing memorials that last for a few tens of thousands of years before fading into the interstellar medium. This expanding, glowing cloud of gas is the very last thing our planet will ever see. The final light show before eternal darkness. And at the center of this magnificent nebula will be the sun's exposed core, a tiny, incredibly dense, and blisteringly hot object called a white dwarf. It will be about the size of Earth, but contain about half the sun's original mass. This white dwarf will be the sun's stellar corpse. It no longer generates energy through fusion. It is simply a cooling ember, radiating away its leftover heat into space over trillions of years. The light from this new white dwarf will be faint, a pale imitation of the brilliant star it once was. For the scorched, molten rock that was once Earth, the sky will finally begin to dim. The planetary nebula will expand and dissipate, and the faint light of the white dwarf will be all that remains. Our planet, now a lifeless, airless cinder, will continue to orbit this stellar ghost in the cold, silent darkness. It will slowly cool, its magma ocean solidifying into a cracked, glassy crust. It will be a tomb world, a silent monument to the vibrant life it once hosted, circling the grave of its parent star for eternity. It's a somber, yet strangely beautiful end to our cosmic story. The final image for Earth is not one of a sudden explosion, but of being slowly consumed and then bathed in the beautiful, ethereal light of its parent star's final breath, a planetary nebula. An ending that is both destructive and exquisitely creative. We hope this journey into the distant future gave you a new perspective on our place in the cosmos. If you enjoyed this cosmic exploration, make sure to like, subscribe, and hit the notification bell for more amazing stories from the universe. And as always, thanks for watching Space Repo.